So, more people than I was expecting, really. I was hoping everybody has to be somewhere and I could relax. But incremental architecture. So now I'll show the agenda in a second, but I want to say, first of all, this talk is not going to be about lots of lines and boxes or architectural patterns or lots of things like this. So I'm not going to tell you, if you have a system that does this, use this particular pattern or stuff like that. It's more about, well, justifying the reason for why we should have an incremental architecture, yeah, and not try to design everything up front or too much up front. But it's also trying to highlight some important aspects of architecture that we as technical people tend to forget all the time. So anything that has to do with people, politics, compromises, and things like this, which are actually extremely important if we want to succeed with anything, especially in big companies, but also in small ones. I found that I worked also with some startups, and I realized that every time you have more than 2-3 people in a place, you have a hierarchy. You've seen those startups with 3 people, and they always have a CEO, CTO, CIO, whatever. It's like you have 3 developers trying to do something. What the hell? Okay? And so it's more about the general approach, how to do, well, to work incrementally and what to do, how to get started and what to consider to try to be as successful as possible, yeah? So the general agenda, the first thing is what is software architecture, a definition of it. The problems with the rational model, now this wording comes from, do you know the design of designs, Fred Brooks, his latest book. So the rational model is, I'll show you, is basically what we try to do when we do full upfront design, yeah? Finding the great design we proceed with. Then what is incremental architecture and advantages? Getting started with it, growing the system. I'll have a couple of slides at the end. I don't know how much we can talk about here, so I've got only 2 slides for this, but being Italian, I can keep talking for as long as so we'll be fine. One thing before we start, I'd like, sorry? Yeah, I'm also British as well. So I'm a bit bipolar here, okay. One thing that I like is, in my talks, is since I already know that I talk too much, I like people to actually ask questions as I go, maybe comments, you raise your hand. Basically, let's not make it a one-way thing, okay? More of a conversation. It would be great if at the end of this session I have learned something myself, or even if I had a fight for strong disagreements, I enjoy that as well, okay? But let's try to make it more of a conversation than a one-way thing. Okay, so let's get started. So what is software architecture? I like this definition from Grady Butch. I think it's the best one I've come across. So basically it says, every software-intensive system has an architecture, yeah? In some cases, that architecture is intentional, well, while in others, well, here should be while in most, is accidental, yeah? But the architecture of a system is the naming of the most significant design decisions that shape a system, yeah? Where we measure significant by cost of change and impact upon use, yeah? And I find this definition very interesting because it's not about lines and boxes, yeah? It's not about the great architects that come and say, I've never done any coding, in the last 50 years, and now I'll draw some lines and da-da, this is the high-level view. It's something deeper than that, yeah? And now we'll see a bit more about this. But first of all, cost of change. Now, why am I highlighting this? Cost of change is a relative value, okay? So if you are dealing with a system that costs to develop 60 million pounds a year, okay, a change that costs you, yeah? Yeah. Yes, it is. It is, and here naming is also to give the correct name, but also is naming as in this thing is actually an important thing. Yeah, we need to. Yes. Yes, but it's also the highlighting of this bit is important, has a big impact. And so here, relative value. Why I'm highlighting this? Because you see, I work with many big companies, okay, where they let's say especially in the past and also now in a project at a bank, where they handle billions of pounds every year. The systems I worked on maybe, well, help them handle billions of pounds. And then you hear people talking about costs. Wow, we cannot do this. It's 2 million pounds. And, you know, in the overall scheme of things, this is cheap, okay? But if you go on a startup with 100,000 pounds funding, yeah, 5,000 pounds is probably significant, okay? So, and we too often forget this aspect, yeah, and therefore we take the wrong decisions based on that, okay? Impact upon use is about how much the users, here users, I use the term in a bit of a loose way. Users also could be external systems that use the one we are architecting, okay? So users of our system could be other clients, hardware, software there, of the system are affected by those decisions, yeah? So let's say that, just a random example, you have a wonderful system that has a REST API, yeah, and then you decide that REST sucks, and therefore you want to have a SOAP API now. Probably the impact of that change on your users is going to be big, yeah, okay, because they will have to change the way they communicate with your system. Okay, anything like this is going to be important, but there is more to it, because it's not simply this kind of high-level stuff. There is an interesting quote that I found from this book. And this is where the definition is of architecture from Grady Butch. It's very interesting. Today's programmers make design decisions about the architecture every single day, okay? When one line of code can tank a required quality attribute, then you are a software architect, whether you identify as one or not. And this is important, because it's not about the high-level stuff. There is no high-level stuff. Basically, there are things that affect the entire system, and things that affect smaller chunks of your system. But it's not about high or low level, yeah? It's something else, it's orthogonal to that. In this respect, actually, in a system I'm working at the moment, I had quite an example of that, tanking the system with a silly thing. Now imagine you handle in your beautiful Java classes username and passwords for logins, and imagine that a programmer that is still learning his trade puts the username in a static field, okay? So, and the bug was found before going to production, but they forgot to put it. Master went to production 2 hours later, emails flying all over the company. We have a problem, okay? So that is a silly thing, seems to be, but is, according to this, is basically an architectural impact, yeah? So we do this every day, so it's extremely important also for programmers to be aware of what architecture is and how things work, and probably to be involved as well. But, you know, we always talk about, and I was saying, the architecture, what it is, how it works, but what is it for? Because sometimes people have no, especially in teams that are agile in inverted quotes, yeah? We don't do silly architecture, yeah? We just code our way through. The thing is, you need to make some important structural choices sometimes. Imagine things like, especially the qualities of the system, yeah? Or using the other horrible name that I really dislike, the non-functionals, yeah? For me, non-functional sounds like something that doesn't function, or that, well, which is actually another correct definition in many cases. But things that have a large impact, you want to have an idea on how to tackle them, yeah? Recording and communicating decisions. So why have we chosen this path and not another one? Yeah, to avoid the guy that comes, you know, to avoid Giovanni that lands in the project at the last minute and say, oh, this is silly. Why are we doing this in this way? Let's change it over, and then everything crashes and burns. Yeah? Guiding implementation decisions. Yeah, sometimes when you are in your TDDing your way through the code, it's like, okay, now there are several paths that I can follow. But which one should I follow? All of them, in the small context of things I'm doing, seem to be equally good. Yeah? But one is better than the others according to the global, the bigger context overall. Okay, so, and that can help. And also, this is an important one. I always, splitting work among teams is something I always have a fight with project managers about this kind of things. Because all we know that the design of the system actually has strong link with the setup of the team or the teams. Yeah. And the way you do that, then and the way you design the system has an influence on how you should set up your teams. And the fights I have is when I have project managers that arbitrarily decide to add a new team or new people to a team without really talking with the technical guys, asking the simple question, do you need help? And if yes, what should I do it for you? Yeah? Okay, because in many situations, especially in big companies, what I find is that the real system designers are the project managers. And then everybody wonders why nothing works. Well, there is a reason. They're doing system design, and they have no idea about how to do system design. Yeah? And what does architecture include? So this is a question for you. What is, what kind of artifacts we have in architecture? Any? Technology decisions? What did you say? Any others? Scalability, that is a quality attribute, yeah? Scalability, latency, performances, these kind of things, but it's definitely an architecture. But here I'm saying, when you say this is the architecture of the system. And this is interesting. Everybody is focusing on the boxes and components. Now, let's have a look. So there are definitely some of the things, static and dynamic views of the system. Yeah, what it does, what is the shape, but also how it behaves. Yeah, sketches. Yeah, what is? Let me. Sketches. That is actually what most people focus on when they talk about architecture, yeah? The lines and boxes, and then we have arguments about the direction of arrows and stuff like this. But then also there are prototypes and reference implementations are important, because those things are important to understand, are we designing the right thing? Are these particular properties like, is it a scalable thing? So if we design a prototype focused on trying to see if we can scale in that way, yeah? You may want to keep that. Documentation, any sort of documentation here, for developers, even for users, for architects, basically something that gives you information about the system. Design and implementation guidelines, again. And these can include any sort of things. Design and implementation guidelines could be also coding standards, yeah? Layout, how you lay out your code, anything, again, on how you should evolve the system, yeah? How do I write my code? What should I do if I add something there? And anything else necessary to understand the shape and the behavior of the system, okay? And the risk points, yeah, that is probably somewhere in between, yeah. But the risks are actually, I think I'll mention later, are one of the important bits, especially at the start, When you are getting started, where do you start, yeah? From the things you understand or the things that you say, maybe here there are dragons behind, yeah? But it's basically a lot of things, but it's definitely not only the sketches, yeah? And this, again, bothers me because some of the, architects I typically deal with, they focus on lines and boxes, but they really don't know about anything else. Actually, some time ago, a few years ago, I was consulting for this big company. It was interesting because they had a new system with the architecture that was beautiful. So I spoke with one of the architects and then said, okay, what is the architecture? And he showed me literally was what? 5 boxes and 4 lines, one on top of the other. And then, ta-da! I said, okay, interesting. What's that? The architecture, okay. Say, well, can you explain me how the system is deployed in the network, how they work, how these things connect, behave? You can deploy anything anywhere. Our components don't need to know. And this, okay, I understand. You must have really, really fast networks because you keep talking about latency and performances and scalability. You don't need to know. What the hell? It seemed to be back in the Corba days. You remember when the objects could talk seamlessly with each other? It's like we already know that this approach doesn't work. Do you? Yeah? So all these things make up an architecture. But also is, let's say, we know what it is. Yeah? But what kind of aspects actually have an influence designing a system, okay? I start today, I need to design architecture for a system to do something, yeah? So there are some drivers, some things I need to keep in consideration, okay? So any ideas on these ones? You mentioned some before, maybe? Yeah. Okay, so now I will add some. So this is people, the teams. What skills they have? How many people you've got? What skills, what technologies do they know? What are their abilities, yeah? In many companies, you don't have a choice. Yeah, it's all well and good and say, hire only the best, you know, give them snooker tables and things and they will come and all this stuff. The thing is, you have to deal with the people you've got, yeah? And sometimes they don't have great skills, but maybe if they are still good people, you probably are able to train them or to help them get better, yeah? As you go, and we'll see that this is actually important for an incremental approach as well. But the skills you've got available are a strong driver for what you should choose. For example, technological choices, yeah? We've got a bunch of people that all they know is Java. You cannot go there and say, you know, guys, for this design, the best language is Clojure. And they go, oh, shit. Yeah. And I don't like brackets either, yeah? Then there is this general, the stakeholders, yeah? Stakeholders here is all people that can have an impact on the system, the ones that give you requirements, the managers in your company, anybody that can actually take a decision on the system, you know, what it does, how I should do that. Those guys are important because it's not simply your users or customers, which, by the way, they tend to be two different categories depending on the system you work, yeah? The users are the ones that will be subject to the whims of your system, yeah? They will try to use it and just complain every day about that. The customers are the ones that actually buy your system because you sold it to them at a very cheap price, or they are friends with your CEO or something like this. But then there are also all the project managers you've got, the managers in your company, because often also the political aspects there are extremely important, yeah? So there is a community out there of people that has an impact, and you have to keep that into account, yeah? If there is something you cannot do is do your grand design and then go there, ta-da, without keeping into account what they want, yeah? Then there is money, yeah? Budget, how much money you've got, yeah, available. Because depending on what you've got, you can have snazzy hardware and beautiful tools with expensive licenses, or maybe you have to make do with whatever is available there, yeah? Or maybe you have the money, but you still have to make do with whatever is available because they don't buy anything for you. Resources. For me, resources is a very specific term. They don't include people. I always have an argument with in companies about that, okay? But things like hardware, software, machines, things like this, things that in a project I was involved with, they asked me to get some performance data of the system and say, well, you know, I need to run this in production because the pre-production one is completely different. No, you cannot do that there. Fine. You have to use the pre-production one. Well, okay, all I can say then is I run the test there, and the speed in this particular configuration is, you know, the performance is this, yeah? And I cannot extrapolate anything. Yeah? And then, of course, there is a line of people asking, oh, you've done the performance test, so what are the performance? Okay, I already told you that I don't know because I didn't run in the real system. But it's the typical scenario, yeah? So any availability of these things. And then time, yeah? When are you supposed to deliver anything? Yeah? The time seems to be a major concern for project managers usually. Yeah? There is the deadline. Generally, the deadline is in the middle of the summer holidays, so it's just before Christmas. But the really important ones are the ones just before bonus time. Yeah? But we'll talk about this as well because actually there are aspects here that are much more elastic than what they seem, especially deadlines and money. Yeah? And then the last one, you know, one strong driver are the system qualities. Yeah, this is a guy that is trying to make a Ferrari out of a Cinquecento after the fact. Basically, the qualities like, you know, latency, security, safety, availability, things like this, usually cannot be easily retrofitted, yeah? So they are strong architectural drivers. They can still be designed incrementally. And probably it's the only way to be able, that we are able to do that anyway. Yeah?
Perhaps also the expected lifespan of the architecture. Is it a thing that...
And this is a very rare one, actually. And this is something that software architects often don't think about at all. And sometimes think about it in the wrong way. So the architect I told you before about the 4 or 5 boxes and 4 lines, when I asked him about this, and so expect a lifetime of 20 years. And they say, okay, right, and what is the average lifetime of systems in this company? Then I asked a few people, it was 4 or 5 years. They say, what the hell are you designing? Obviously, it's not gonna last 20 years. Well, besides that particular thing wouldn't last 6 months, but for other reasons. But that could be an important one, okay? But now that you know about this, the drivers and what the architecture is, so let's have a look at what Fred Brooks calls the rational design process. That is, yeah.
I think that point that's been made there about lifetime, and the point was made over there about scalability, actually more important than just being in that box, property. Because if you're intending to grow an architecture, that system,
Yeah, you know. The thing is, but also it depends, yeah, because also scalability depends on what you mean there. You know, if you want, depending on the product, you want to scale from 5 people to 500, or the product you say we start with 5, but then we go with 5 million, yeah, the things are very different. It depends, you know, but obviously if there is this need to grow the customer base, the scalability can be a really major one, yeah. And the lifetime is actually important for the technologies as well. You know, you have to have a fair idea of how the technologies, at least I guess, are going to evolve. But the rational design process, which is basically what the waterfall model, the big upfront design model is based on. Yeah? So it's like you have a goal, then you use the terminology here, desiderata, that is not very stable, is it? That is kind of secondary goals. Yeah, you have a main goal for your system, you want to achieve something, and then some other things. Yeah, ideally, you should be able to scale up to this. You know, maybe some stretch goals or things like this. And utility function to decide if your design is good or bad. And then some constraints. You know, budget, time. Some of the drivers we said before. And then the algorithm is until the design is good enough or the time runs out. I think usually the time runs out before the design is good enough anyway, is do another design to improve the utility function until design is complete, yeah? And while design remains feasible, make another design decision, yeah? And then, and that while, back up the design tree, basically it's trying to navigate the entire design tree to find the best possible design, complete, and once you've got it, then you can implement it, yeah? Which this is what is basically the mindset behind the big upfront design thing. Yeah? I didn't, well, it doesn't say that it's a good one, okay? So if you look in the book, it's basically, I think it calls it rational because it seems to be, is the kind of thing that we naturally tend to think that is the rational thing to do. Yeah, it's not because it actually is. It looks like on the surface. Yeah, and obviously then in the book it just destroys the model. Yeah, but this is the thing. When we do the upfront approach, tends to be try to find the best possible design at the beginning, yeah, and then do everything later. Yeah. Obviously, with this approach, there are a few issues because the rational design process doesn't work. You know, life is messy. We usually, when we do a design, it's kind of, you know, you start, then you go to the end, but then you backtrack, go all over the place, back again. And there are some interesting reasons for that. One is that design is not just to satisfy requirements, but also to uncover them. Yeah? And this is a very important point. When we design something, we are always, okay, now I'm understanding, then you do this, you show this to your user, saying, this is not what I meant, really. Can you change this in this other way? Yeah? And if we don't keep this into account, we get extremely frustrated by that. Yeah, I've seen developers and architects being really upset by that. You know, we did what they told us, and they, you know, and they sent us back to redo it. I've had enough. But it's actually an important thing because, especially if it is a new system, yeah? If it is not a kind of boilerplating thing that you do all the time, people don't understand this, yeah? And this happens also in buildings, yeah? If it is the standard boilerplate British house, probably there isn't much to it. The design is very stable, it's always that. But then if you go the new skyscrapers in, where is it, in the Arab Emirates, in Saudi Arabia, the 1,000 meters tall, that is a completely different thing. Probably they go back and forth trying things before trying to build the structure, yeah? It's not simply design it once, off you go, do it, yeah? There is this aspect there, yeah? And also, it's not about simply selecting from alternatives, but also realizing their existence. Yeah, so it's not that you really know what all the possibilities are. Sometimes you discover some new ones. And this is actually linked to the last point, that this, for me, is an important one, that often the domain is not well understood even by the domain experts. What I found, and this is linked to this one, so actually the domain experts often, at least in my experience, are people that are domain experts because their expertise comes from using an existing system. That's the domain they know about. And then when you create the new one, what their expertise is about, I want something like this, but better. And then you start discovering some alternatives. Say, hold on a minute, do you realize that with this new system we can actually fix this other thing with this alternative? We can actually do new cool stuff that is impossible with the existing system. And you start having this conversation. So it's quite interesting. In a previous project, I had exactly this with the domain experts that didn't realize that with the new system we were designing, we could offer them a load of new opportunities and interesting things for the business. Yeah? And we had to help them to understand this.
Isn't that pretty much the definition of expert, that they don't really know what they know because they internalized it?
Well, but some of those guys don't really know anything, but they are declared experts because what they know is based on their current knowledge of the existing thing.
Surely the expert is the person who is open to accepting that they didn't know something before, and they do now.
You know, I agree. The thing is that it depends on how we define experts, because sometimes we realize that if you declare somebody an expert, many people are actually reluctant to admit that they don't know some things, because otherwise they don't look experts anymore.
Yeah, but you see, for me, I totally agree. That is a fundamental attribute of the master. Is the person who is happy to stay there and say, well, actually, you don't know, I don't know, we need to work together.
I agree.
And for me, I think I would define the expert in terms of what I said earlier, in terms of the risk. They're the ones who know where to look to go and find
The important, yes, yes. Yeah.
One approach I heard was an expert is assigned, and it's like, you're now the expert. You don't know anything yet, but you're the go-to guy, and you become the expert because everyone is asking you, what about this? Or they're telling you, no, you don't know.
So you are kind of forced to find information
Exactly.
and
so it's
get
just, expert is not meaning that you know everything, it's just the person who collects all the
But also his point of view is actually someone that knows where to look or how to act to find information. You don't necessarily have it, but you know how to get started in fact-finding. So with all these things, actually, I think that my belief is that the chances of success of a big upfront design are inversely proportional to the size of the system being designed, which basically means the current wisdom of many big companies is totally wrong, because the attitude is often, this is a big system, we need a big design upfront. No, this is a big system, so probably have lots of risks, lots of unknown, and lots of things you need to check before you are even starting to think about the design. Yeah? With a small one, it's easy to do big design upfront. I always do big design upfront with my CSV parser when I have to write one on the spot because of something. Yeah? I just need this, a class here that does this, ta-da, Python, done. Actually, in Python, you even import the module, so you just need the design is where do I actually call the thing. Yeah, that is big upfront design. I already know where I'm going somehow, yeah? But it's tiny. But that said, I think the big upfront design is actually a red herring. We keep focus on that, but the problem is not the big upfront design, okay? The problem is the speculative upfront design and the absence of refactoring, because basically what we see in most projects, or at least what I see, is not that everything is designed upfront. It's that there is a lot designed upfront, lots of things that are left for later, but the problem is that this upfront design has some speculation in terms of we want this part flexible because in the future, blah, 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 yeah? Or here will be reusable. Unfortunately, the future doesn't listen to us, and is always flexible in a different direction, or what you thought it was reusable, nobody, not even you are going to use it once, yeah? So the speculation part, I think, is a big problem. So there is lots of design, it's not fully fleshed out, but what is there has enough speculation that it creates a problem later on. Yeah? And the absence of refactoring. So people that come up with a grand design, then you have new functionality that really doesn't fit the thing, but since the design is done, you have to shoehorn whatever you are coming up with into this thing. Yeah? Instead of understanding that perhaps it would be better to reconsider what you've got there and change the shape a little bit to accommodate everything in a nice way. Yeah? So what is incremental design here? So according to Gene Shore, incremental design, that is also called evolutionary design, allows you to build technical infrastructure such as domain models, persistent frameworks incrementally in small pieces as you deliver stories. It obviously uses this vocabulary because this is about agile development. So you can replace stories with functionality or requirements or something else. Yeah? But the idea is always the same. So basically what you do, and the graphics here is wrong, but then I fix it because this is more iteration than incremental to me in my mind. But it's basically one small set of features at a time: design, implement, test, deploy. So you evolve the design as you go, yeah? Okay? And obviously, one more thing, adding increments is not enough. You need to iterate as well. So let's talk about this a little bit, because many in our profession confuse incremental and iterative, yeah? So incremental is adding things, yeah? You make your thing bigger. Iterative is you revisit what you have done to refine it, okay? And this is extremely important because in many situations, also in agile teams, what they expect is that you just go incremental but not iterative. You do the thing perfect the first time, which is not good, yeah?
Maybe your previous slide fits into this, the speculative, the big upfront design, and just below refactoring, you make a hypothesis, and maybe you think I have to select later, and it doesn't work out that way, so you have to be able to refactor that out again.
Yeah.
So
there is that, but this is also about, sometimes you deliver something according to your current understanding, and it does what it's supposed to, but doesn't have all the full bells and whistles, yeah? Maybe the functionality is there, but it's not 100% usable in a nice way that flows with your users, but still it's there so they can at least check if it is the right functionality. Yeah, and then you refine it a bit with the feedback, yeah? But then also, when you do this iteratively, it's like at some point you can stop, say, okay, it's enough, yeah? Okay, so in a way, iteration is a form of increment. It's a kind of an incremental refinement, if you like, of what you've got. But it's different from, iterative incremental, two aspects, yeah? And you need both. They are not the same thing. Could be that. More elegant design or more refined user interface, more, basically the functionality stays the same, but it's better. You can use it better somehow.
I think it's what the term of topology duration involves a loop, whereas incremental approach is linear.
Yeah.
So, yeah, I was going to say, so is what you're saying is iterating, is that across the system, or is that iterating?
Well, across where you need to, because generally you do this in small chunks. It's not, you don't redesign the full system all the time.
The question here is treating the system always as a whole. So if you add something, you change the system the rest of it may also have changed or be in a position to be changed. So if you think of it as a sort of global optimization process, each time that you make an addition, you've got to re-optimize the entire system.
Yeah, but also if you work in a clever way, you don't have to actually change everything every time, okay? Well, we'll talk about that, because when you have this approach, working increments also means that you need to travel light. You don't bring lots of stuff with you. And when you do that, it's actually much easier to change the system as you need to. I'll touch on that point later.
That's when you get to cross-cutting concerns.
Well, I'll touch on those points.
But at least even if you try to work locally, so that you can focus on one thing at a time, at least you should check whether you're...
Yeah, but it's not simply locally. You have to, the global context has to be there, but you can actually make sure you can work in a way that you don't affect too much of it, at least most of the time, yeah, unless there are some really major changes. Yeah. And so the interesting thing about an incremental approach is that it can also alleviate or remove some constraints. So early production, early revenue, fewer budget restrictions. And I'm talking from experience here. A project where I joined, there were a few issues with the customer, we managed to deliver things, start delivering, and somehow the budget that was fixed grew because they started to get customers, cash flow, and they were satisfied with what we are doing, and so the budget constraint became much less relevant. Yeah. If you go with a big upfront, with a too much upfront design, often you finish the budget before even starting to do something. And also with the team skills, sometimes if a technology is something that you really need to use, when you go incremental, you can actually learn the technology while creating the system. So if you work in clever ways and design the things accordingly, you can create an opportunity where the team skills are being actually improved while they do the work and deliver stuff. Yeah? Which is another benefit of this. So it's not simply we design things, you go on training 10 days, come back, and now, you know, it's much less expensive and a much more interesting way of learning things. And often, important deadlines can be met with just some basic functionality. You don't need all the bells and whistles sometimes to satisfy some deadlines. Yeah? This is particularly important if you work with banks and they have regulatory constraints. Yeah? Anything you can deliver there that will satisfy the regulator will be fine.
Did you ever encounter clients which were the other way around? It's like, no, we don't want incremental, just tell me when it's done, and then I will try it. I won't be happy.
Yes, and this is part of the getting started in terms of how to play the political games there and talking with people, and this is part of the things that need to be solved on the human side of architecture. So, and also the thing is that the incremental approach allows to create the right domain model for the application. Now, again, here this is important because often people talk about domains as in the automotive domain, yeah? Banking domain. Now, automotive domain, there is the Formula One cars, and there is the Fiat Panda. And probably the software for the injection of the Formula One is slightly different from the one of the Panda. And your design probably focuses on different things, you know. Yeah, so on the Panda probably you want, well, a low fuel consumption. Yeah, you don't want to go too often to the mechanic for maintenance. Yeah, and stuff like this has to last ideally, I don't know, 50 years. I've seen people with 20 years old cars, stuff like this. With the Formula One, you probably want very high torque at some RPMs. You want the thing to go from 0 to 60 miles an hour in 2 seconds or less, or stuff like this. Maintenance, you don't really care. As long as it lasts for one race, and then the engine breaks, it's fine. Yeah, well, yeah, now then they introduce regulation about you have to use it for like 2 races, and they go, shit. But the thing is that the constraints are very different, okay? So even the system you design, you know, the software is probably very, very different, okay? And I'm pointing this out because people often talk about domains in a way that is a bit too broad. Yeah, so the domain is generally specific to the application and the problem you are trying to solve there. Yeah. Then, of course, it could be part of a broader thing. Yeah. Because probably the software used for the Panda can be used also for the Fiat Uno with small modifications, so a kind of product family, something like this. Yeah, but it's still within the same global, more or less, constraints. Yeah. Okay. Does it make sense? So, why do I don't know why this slide, something disappeared from here or moved sideways. Apologies for this. But the thing also with the incremental approach, the problem sometimes is how do we address qualities? Because when we talk about, scalability, latency, security, often the qualities are used as an excuse to have a lot of upfront design without actually knowing the system, because they say, they are system-wide concerns, so you really need to design them upfront, which is, up to a point. Yeah. So if you know some of the qualities you have to satisfy, things you can do is some research. Maybe there are some architectural patterns that could be helpful in your case. Yeah. Look at what is around. So to have an idea, yeah, on how to try. Hoisting means basically you design your system in such a way that actually that the quality is satisfied almost automatically. Just a random thing when the J2E stuff with the Java beans and all the grand design Sun came up with there was hoisting lots of things there to guarantee some qualities of the system in terms of some performance things like, you query the database in this way, you scale the system in this other way. I'm not saying that was successful at that, but that was an idea. But another example was you want your REST system to be secure somehow. You have HTTPS, and you are doing this Java, you can grab some libraries to do that, and then some small things to actually do the mapping for the JSON or whatever format you send the data to. But basically, it's the fact that you are doing HTTPS there, the security is guaranteed by the security of HTTPS somehow. Yeah, you don't need to redesign the thing all the time. So hoisting basically means you can put some things in the system in a way that you almost don't think about the quality attribute anymore. Yeah, but also prototyping. This is important because again, really we are not able to design everything up front. So if you have something in mind, it's better to test our ideas and have some initial design. Very small things, say, we think that this kind of shape will guarantee this particular latency or performance aspect. Yeah. But obviously, you need then to refine it as you find new information. But there is no need to try to design this from the very beginning. Yeah. And also things like scalability. Systems I worked on where, for example, we use this installation on AWS with the Postgres. And things like this, we had almost horizontal scalability due to the way the setup in Amazon was, because they could do Postgres replication for us without us doing anything, just a few setup things. Replication of our servers, again, spinning up new instances as we needed. So basically, there was a level of horizontal scalability that we really didn't need to do much to get that. Yeah. This is what happened there. Probably there was some kind of effect that I didn't want and ended up there. It was just the representation of the qualities.
More often than people over-investing in upfront design to come up with an architectural style or pattern, as you say here, more often I see people choose architectural styles just because they're fashionable. I mean, microservices is the thing right now. And all people designing highly distributed systems, when in fact you can go out and buy a computer with nearly a terabyte of RAM.
And they really don't need that, yeah. That is a problem. That is a major problem. I actually had, last year, in a project with Microservices, I landed in this project. It was interesting because there also there was all the mistakes about the domain and everything were there. We want a microservices architecture. Of course, if you ask the question why, there was no answer. Yeah, because they didn't know that. It's microservices. Obviously the monolith. Yeah, But the thing was also the domain. This was about tracking people moving around dangerous places and potentially send the special forces and grab them bring them safe home. So, but the microservices, when I joined the team, were interesting because it was like, we have a microservice for countries, a microservice for people, a microservice for trips, and then we have a requirement, oh, shit, there is a bomb going off in this place. How many people have we got there? It's like, we cannot query this. Because the only way was query everything in memory. And so we started to actually merge things back together. And then doing that, all the important requirements were actually met. The problem there was, you see, it's like the domain, we seem to classify things in broad categories that tend to be some kind of general, universal ones, when in fact, sometimes you need to look at the problem differently. In that particular system, the important thing was not, in many aspects, the country or the people, was the relationship between them. That was the domain concept that was important. You know, how many people have we got here? Or where is this person? Yeah, stuff like this. But separating things right at the beginning, in a way that seemed to be rational and logical, yeah, screwed it up. Then let's not even talk about, availability and stuff like this. You know, if one of your services goes down, what happens? Or things like, why is this thing is a microservice architecture, but we have to install all the services in a specific order, which was another issue.
Isn't that really the point that people doing fashion-driven architecture are actually abdicating responsibility for thinking?
Yes, yes. But unfortunately, we cannot get rid of them because we would end up in prison. So but it's a common thing, but it's a common thing with anything in our profession. You know, languages. My language is bigger than yours. It's just, the people obsessed with things that are actually relevant. But, happens all the time. And unfortunately, I don't have an answer for that, except when I join a team doing those kind of things, I can get really upset. And then start shouting maybe, or I don't know. I actually try to help people go in a different direction. Yeah? So after I said that, okay, how do we get started then? It's all nice and well, so what do we do? I want to do my incremental architecture. Giovanni convinced me. I go to the office tomorrow. What do I do? Yeah, work on a system. So let's see. First of all, if the politics don't fly, the system never will. One fundamental thing that any person designing a system, and not only about the architect, but people that are involved in creating the system, they have to understand the politics of the place. Yeah? And as I told a few colleagues that they hate politics, I told them, look, either you engage with politics or politics will engage with you, and you won't like it. Okay? So this is important because there will be conversations, there will be desires, wishes, and you'll probably have to find some compromises, okay? You won't create your work of art architecture, but you'll create something useful. But you need to engage with the politics, yeah? Then the other thing is engage with the stakeholders and the development team from the start. So if you are in the development team, and the development team is doing the architecture, basically they need to be involved right at the beginning and given access to the main stakeholders, okay? If you're in a situation in which you are the design, the architect somehow, and are separate from the team because of the particular setup of your company, which happens, engage with the development team immediately. They are the guys that will do the work, and they will have feedback to provide, and they need to be involved. Because what happens with developers is that if you give them an architecture and say, go off, this is the design, you do it, if they don't like it, they will do whatever they think is best. And the best thing is that you will never realize that. Yeah? So that's extremely important. It is actually in some consulting work I did was exactly what I did to solve some major issues. You know, the architects that don't code, don't even know where the code is, but they come up with a design and estimates as well that are imposed to the team. Yeah? So solution to that was put people from the team talking with these guys from right at the beginning. Yeah? And obviously engage with all the stakeholders as well. Yeah? Okay? And this engagement is very important when you have an incremental iterative approach because you have to engage more often. Yeah, it's deliver something, do something, so you'll see the stakeholders more often. They won't wait 6 months for you. They will receive stuff continuously, ideally, yeah? And so you have to somehow make those relationships work. Start small, okay? No grand designs, no cathedrals. Start small, yeah? This is from the Systems Bible. A complex system that works is invariably found to have evolved from a system that worked. The other way is not true. Okay. A side effect of the start small is that often if you start small, then you don't really need to grow much anyway. Yeah. Focus on what you know. Yeah, I think, no, this is the new title. This is the new title. Yeah, before the previous edition was Systemantics. I don't know why they changed title, actually. Systemantics was much better. But then focus on what you know. Here, what I mean is not that is, there are unknowns, ignore them. But, if you know that there are risks, you want to address them. Yeah, if you know that there are some things you have to do anyway, yeah, focus on those. Try to deliver those, yeah. No speculative upfront design. Don't. Yeah? Design around the things you know and try to design uncertainty as much as you can a bit down the line. Yeah, of course, explore potential risks you know about or you can. Sufficient design, yeah? Whatever is sufficient, yeah? As little as you can get away with, basically. Now, you take your dictionary and remove the pages with reusable and flexible in it. And if I'm around, just don't use these words, please. They are trigger words for me, with violence and bad responses. Yeah? Don't think about it. Things always flex in the wrong way, and until you use something, you don't know if you are going to use it again. Yeah? And address major risks that you can think of. Yeah? Okay, and the ACCU can always have to have a quote from Kevlin. Yeah.
And do people in this sort of field use rich pictures as a tool?
Sorry, say it again. Do people?
Sort of doing these startups and architecture jobs use rich pictures.
Rich pictures. What do you mean with the rich pictures?
Well, it's a technique from sort of each check and of information system design and socio-technical.
Mm-hmm.
Whereby you try to capture all the things in your last two
okay.
slides in a single picture.
Okay.
Totally free form. But people just create
okay.
a work of art
yeah.
that encapsulates the stakeholders, the doers, and what the number of the goals are to try and give you a representation of socio-technical.
Yeah, I don't, usually what I see, I don't think I've come across rich pictures then. And what I usually come across is people is just lines of boxes of system, forget even the dynamic view of stuff. No, that's irrelevant. Yeah, I understand.
Really help in terms of contextualizing the people, the work, the functions,
yes.
and so on and so forth, in a form that's generated by the team.
Yeah, I can see that being.
I've got a few examples.
I'll look into it actually because it seems to be very useful. But now, here, Kevlin, from the 97 things every software architect should know, favoring simplicity before generality acts as a tiebreaker between otherwise equally viable design alternatives. Yeah? When there are two possible solutions, favor the one that is simpler and based on concrete need rather than the more intricate one, the intricate one that boasts of generality. Yeah? Don't try to overgeneralize. Just solve the problem for now. Yeah? I usually say people travel light. Yeah? Don't put too much stuff there. Solve the problem in a good way, and then if you do that, you'll probably later on discover how to make things general for your particular needs in the system. Yeah? This is, I quote myself, and actually I'll do this as well. Choose your tools with care. Okay, so another trigger word for me is framework. Okay, Especially if it is Spring framework, then I just leave the room, because otherwise I'll kick some. But sometimes I see this in many developers is, okay, what do we need to do? Before even asking, they go, we need to have Spring, Hibernate, whatever, yeah, the things. Now, tools, frameworks, things you use, there are some that are useful in some contexts, but in other contexts are not. And they will impact your ability to actually evolve your system. So you have to be extremely careful there, yeah? And especially with Java, where the version management of the jar really is non-existent, yeah? You have to be extremely careful if you have different frameworks that interact with each other, because then the upgrading of the various versions can become a real hell. But the idea is, be careful there, yeah? Choose whatever you're using based on the needs you have, and generally what you choose comes at a price. You have to be ready to pay the price for that. Could be more difficult maintainability in some aspects, or I'm not talking about license fees here. I'm talking about, work needed to take care of your system somehow, yeah? Or possibilities that you close down because of the particular tool, yeah?
I think one might distinguish between the tools you have to use, like infrastructure, language, compiler, and the tools you can use during development.
Mm-hmm.
Let's say, for delivery, you have to use at least GCC6, but you can opt in for using a newer one.
Yes. Yeah, but you have to be careful, because you need to manage the thing. You want to grow the things incrementally. Sometimes don't start too early with some things. Yeah.
Consider on what you depend on.
Yeah. And also there is another aspect, so people can relax a little bit, that is, you may have an idea of the final shape of the system. This is not forbidden. It's actually very useful. I always have an idea of the final shape of the system. However, that's just an hypothesis. It's an hypothesis. It's not the design. You think you'll go in that direction, and therefore you take some action based on that. Yeah, but also you know that you are going to probably change that. Yeah? Okay?
Can we go back to 97 things for a moment?
Mm-hmm.
That bit about choice of tools. I think there's a lot in there as well about communication and the fashion-driven development.
Yes.
So you may have somebody very keen to have the shiny new thing, but they haven't really communicated with the team about why this is a good thing and why we should move from here to using something
Yes.
different that we're not familiar with. It's something that's come up a lot in my interviews with programmers. People rushing off to do that. It's not been a team decision and justified the case.
Yeah, often the people that rush for that, they don't tell the team because they don't have any reasonable justification.
But it should be mandatory to
Yeah.
talk about it.
Yes.
Do it.
But also, what I was saying here, so here's an hypothesis, so test your hypothesis. Coding actually makes sense more often than believed, yeah? So you have an idea, well, get something done according to that, implement part of your design, and you may see that if you're in the right direction or not, yeah? Okay? So so every time I hear an architect that says, I'm an architect, I don't code anymore, okay, for me it's just enough. I've heard enough from you, bye. Okay, because it's a way of getting feedback on what you're supposed to do.
The hypothesis thing is interesting. Maria Petri gave a keynote here 2 years ago, and she talked about provisional knowledge and the capacity to cope with provisional knowledge, and realizing that you only have a hypothesis at the moment.
I wasn't here, so it's interesting to me.
Yeah, unfortunately, I don't think the video worked, but she was saying that in studies they've done, that is what differentiates the more successful teams
From the less successful.
The fact, can you cope with the fact you don't know enough yet?
Yeah.
You don't over.
I can see that, yeah.
Same
That
with
was,
tools.
yeah.
Tools can have a direction.
Yes,
And you need to be aware, almost like a meta issue, that there's a direction.
yes. And also an important one, don't fall in love with your design, okay? You are not designing a great sculpture, a picture, or anything that is art. You are solving a problem for somebody.
Yeah, it's exactly the thing I was going to say. I had the feeling in my career that when a developer graduates to, well, feels like graduates to architect, he starts thinking like a painter or something like he's going to make a nice picture, and then put that under a glass case, display it on the lobby, and say, see, I designed that.
Yeah. So don't fall in love. Also because, you know, with all the politics and things, probably you'll have to compromise on something. So the important thing is that you solve a problem in the best possible way in that particular context, yeah? And so there will be conversations, even maybe frustrating ones, but also compromises and choices. Sometimes you are forced to take some choices because someone decides that, yeah?
What's that phrase that they used to advise to authors? It's something like kill your darlings. You have to let stuff down, go. You have to
Yes.
Is it kill your darlings?
I don't know the phrase. But I can tell you that on my is sometimes in the past I needed to learn to stop. You know, sometimes when I was leading team, I saw things that people problem solve well, but not in the way I would have solved them. You know, the urge to redo it, but then you say, okay, hold on a minute, what are you doing? If they do this to you, what is going to be your reaction? You need to learn to just step back, you know, things are working, or maybe you can have a word with people just to understand, and maybe things can be changed, or maybe they're just well done and you don't know, but, you know, don't fall in love with your things, yeah? And then proceeding with the design. So the thing Alistair Coburn suggests is the working skeleton, yeah? Tiny implementation of your system that address a thing end-to-end, yeah? So when you work in incremental architecture also, you don't want an incremental database design, and then when you're done with the database, you do an incremental business layer design, and when you're done with that, you really want incremental everything. You want your system to evolve as increments, yeah? And so the idea here is, let's say you have, this is Lens boxes for you. So it's like you go like client server with a database kind of thing. The next step, if you put new functionality, you do, again, little bit, you see the lines of the client, little bit of the server, and the little bit of the database. So you affect all the parts of your system that are relevant for that feature. And this is actually much easier than what it seems. People always, you know, work in user stories. We cannot make the stories smaller or things like this. It's generally, they are, well, so far in my experience, they are wrong 100% of the times. It's just they don't look at the problem from the right point of view. This is because I actually train people to look at the problem from the right point of view. So, and I generally challenge them, like, bring me the story, the most horrible thing you have that is unsplittable. And 4 hours later, they left the room with things like lasting 4 hours, more or less, and completely surprised. Okay? So it's always possible. Obviously, what you cannot do is necessarily deliver the thing to the users all the time. You generally need a critical mass of functionality there for the system to be fully useful. Yeah? Also, there is the variation that Goiko Ajik says, skeleton on crutches. That is, and I've used this technique quite a few times. So you say you start, instead of, at the beginning, you just want to solve the problem end to end. So instead of using the database right away, you use here the file system, and then you put the database later on. This is pretty effective, you know, because to use Oracle, you're in a bank, you have all the clearing from your database people that are somewhere else. And in the meantime, you still want to deliver something that works, and you may use a database, file system, and then you do, of course, if you have to do the design appropriately there with interfaces and everything, so when you put the database, you don't have to redesign everything, yeah? I'm assuming you know that, yeah? But it could be a very effective technique as well.
I think that's particularly useful. You perhaps don't even know you do need a database, but also the database isn't the risky bit.
Yeah.
So you want to
yes. Yes. Yeah. So you're saying, you know, sometimes you want to use the database, but it's not the risky bit, and you want to make progress on the risky bits, and it's faster for some reason to do that, then you do that, yeah? And also, or things like extracting a service. So we talked about microservices before, yeah? I'm very much on the school of thought that monoliths are not good things, are not bad things, are actually pretty good. And I always suggest start with one thing, one system, and then go to two when you need to, yeah? So here the approach is, you know, we have our system, then you say, oh, hold on a minute, we want to extract a small service, and you go in steps there. Maybe you initially say, you know what, this will become the service, and this will be its own database bit. Later on, you maybe extract the database. Now at this point in your code, probably have two database connections somewhere initialized, and then you extract the service itself, yeah? Obviously, the thing that many teams don't understand here is the most important bit here is this line. When you extract the service now, you have latency, you have potential issues with fault tolerance and availability and stuff like this. Yeah? So this is the kind of thing that if you are thinking, an incremental way to do that, you stop and say, okay, what problem are we solving here by this extraction? Why do we want to do this? There could be very good reasons, yeah? But that small line there here needs to be considered very, very carefully. But again, if you work in this way, at least you have this possibility, yeah? To consider the problems there, yeah?
Or maybe if it turns out bad, you can convert it and revert it back.
Yeah, exactly. The other thing is design for testability. Now, I don't have the quote here, but Rektin said, for a system to be testable, it has to be designed to be testable. You probably have this experience, yeah? And I love when I work with teams that say, why don't we use TDD, unit test? Well, we don't know how to do that. And then they go, okay, the code is done, now I have only to write the tests. And then I just watch, because buy popcorn, some beer, and enjoy the show. But it's a very good learning experience, yeah? But design for testability is a fundamental thing, because remember that the main purpose of automated tests, so here I'm talking especially automated tests, okay? A level of manual testing can be useful, yeah? Especially if it is exploratory testing. That is, for me, the real manual testing I want. Anything else, I'm not that interested. Or usability testing, yeah? The main purpose of automated tests is to make the system maintainable and evolvable, okay? It's not to prove that the system works. Well, of course, that is a side effect. But then, as you go on and increase the system, you don't want to be in a situation where you introduce regressions, okay? So every time I hear the argument against test automation and tests and things, even by some big friends of the ACCU that are not at the conference this year, which I won't mention the name, he has very strong opinions about unit testing and this stuff. My opinion is that they are wrong. And my opinion is an informed one, because as a contractor for years I landed in random code bases where if they had tests, the code could be as bad as you like, I could do something with those. If they didn't have tests, I had a big problem in my hands, every single time. Okay, so if you are working incrementally, this is a fundamental thing. You cannot do without it, yeah? Because remember that when testing is done right, it is almost unreasonably effective at uncovering the effects that matter. Despite what Dijkstra said, about the test not proving the correctness of a system, you don't want to prove that the system is correct. You want to prove that the system is statistically good for what you need it to be, yeah? So there are ways to deal with potential issues. It's like the missions of the space shuttle were timed in a specific way because they knew that the mean time between failures was like more than, say, 10 days, and they timed the missions on 1 week, stuff like this, yeah? So you can do these kind of tricks. So you don't want perfection, but you want to be able to actually scale up. If you have to do formal proof of correctness every time, try to refactor your code and do formal proof again. Yeah? Just doesn't work. Yeah? And then you need to create feedback loops. Yeah? So continuous integration, continuous deployment, and continuous delivery if you can. I would say that continuous integration has always to be there. Yeah? Continuous deployment and continuous delivery are kind of optional, but continuous deployment is good if you can. Continuous delivery is fully optional because that depends very much on the system you're dealing with and the context. But if you're in a position that you could implement this easily, it's a very good thing to do. Yeah?
Well, how do you differentiate the deployment and delivery?
Because here what you do, the delivery is when you put the system in production. Here is in your internal test system, maybe, yeah? Something like this. But the step from here to here, if you work in a, obviously if it is a system you can deploy from in your company, because if it is something you sell as a packaged software, probably you don't do the continuous delivery, yeah? But if it is an enterprise system, often you can. But you can be in a position where you always do this, and then you push a button and you just deliver it, yeah? Instead of, it's not continuous, but still is much simpler than, doing this by hand all the time. But this is important.
Just a single data point, nothing statistically significant. Place I went to do some work, they wanted to go to continuous delivery, have the whole thing automated from commit
Yes.
of source code through to continuous delivery. And they
Yeah, but that's,
Simply for legal reasons.
that's fine, yeah, that could be. Because sometimes also you have, yeah, legal reason, regulatory requirements. Sometimes you have to have, because of legal reasons, someone looking and maybe doing some manual stuff on it, but it's fine. But if you're in a position where you could do that if you wanted to, it's a very good position to be, yeah? TDD at all levels, yeah?
Maybe if your continuous integration takes a little while to execute, depending on the size of the system and the amount of tests you have to run and the time that needs, maybe it's still not worth the effort, because if you have to wait, let's say for a couple of minutes, or for that to give you the answer. So it's like a context switch in a program. It's very expensive, it takes time, distracts. Whereas if you have a fast feedback loop and it only takes a few seconds, sit down and wait a few seconds, because it's not worth starting something else.
Yeah, that's it. But also, remember that with automation, even if the feedback loop is long, you know, because, I don't know, some tests need to be rewritten still, the fact that it's automated is still an advantage, okay? I've seen companies hiring armies of test, well, what they call testers, but it's basically human bash interpreters. You know, they give them the script and they go click, 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 because they didn't have automation, yeah? TDD at all levels, so outside in, this helps, yeah? So because in this way, you can actually create a testable system from the outset. You can write your integration system test at the very beginning, and you can create all the proper hooks you need for testing your system, yeah? You cannot really design testability after the fact. You know, I wrote the code now, I wrote the test, and it's like, hold on a minute, for this one, I need to access the database sideways now, because I need to check that this code, this data has been put there in the appropriate format or stuff like this, yeah? Or I need to check that the queue received the message, but I don't have the API to access it in the way I want, yeah? If you do instead with a TDD approach, basically writing the test at least at the same time, if it's not fair before that, you will get a great advantage there. Things like, so I'm putting this here as a special things because they're often forgotten. You know, the fact that you can build a system, deploy and configure it, and some versioning strategies, these can be part of the architecture, they're important. Yeah, these are the kind of things that people do always at the last minute, and then it's difficult to do anything, yeah? Configurability affects your ability to test the system, for example, you know, configuring external resources, databases, queues. Like deployability, if you cannot deploy by one click, but you need a manual process of, you know, 1 month of people sorting things out, that's a problem. Yeah, even the incremental work will affect your ability to work incrementally, also towards the architecture. Yeah, buildability, I want to check out, click, build. Yeah, again, all these things that can actually be, they can be impediments towards your iterative and incremental work, also towards architecture. So they should be taken care of at the architectural level, basically, yeah? Even if they have an impact that seems to be technical, the fact that you can have to deliver late because of any of those problems, yeah, this is something that will impact your customers. I think we are running out of, well, we ran out of time. I'll try to go slightly faster in the last few slides. Architectural tasks in my workflow, sometimes, you know, how can I do that, include them? Well, there are some patterns that can help you out. This paper is public from Rebecca Wirtz-Brock. You know, architecture in the backlog, architectural trigger, architectural spike, basically means sometimes when you work in an incremental way, you know that there are some parts of your design that might become pain points. An architectural trigger is something along the lines of, if this happens, we need to reconsider this bit of the system. Yeah, and then at that point, you may want to redesign some parts or refactor the design, yeah? But they are all about choosing when to act on the design of your system. What is the right moment and what to do, yeah? Architectural spike, we reach a point where we are not quite sure here what the design should be. Then you try to understand what the risks and the potential issues could be, and you can have some spikes to focus on them and get some feedback so you can take the design decisions, yeah? I suggest to download the paper and read it. It's very useful, yeah? And technical debt management is about how to, well, when to actually fix it. In this respect, also technical debt is not the debt that you accumulate because you are doing arbitrary things in your code, okay? Technical debt here means decisions you have taken in an explicit way, saying, look, this is a shortcut, and I know that it's a shortcut, but I need to address this problem now, and I can do this in this way, and later on I'll have to pay a price for it. Yeah. Otherwise, it's the debt that you go to take with the Wonga.com and those kind of guys that is, you know, paying 4,000% interest without realizing that. Yeah. Okay. Documentation. So this is paper from David Parnas. I hope you all know him. A rational design process, how and why to fake it. This was written in 1986 with Paul Clements. And David Parnas obviously is a giant of software engineering. And here, basically, Parnas says the core of the paper is the design process is messy. Yeah, you do stuff. It's difficult when you get. You have to, you know, prototype, try things out. But then at the end, you need to show people your architecture and document. So what do you do? How do you do that? Well, you do that at the end. And you make it look as if it was a linear process, so people will actually understand, because the purpose here is not to show how you proceeded to design, it's to actually give people information about what you came up with. Yeah? And you can do this incrementally with each increment. Yeah? Growing the system. So I've got the last two slides. We are 8 minutes, 9 minutes late. Can I go on for a couple more minutes? Okay, thank you. So this one, I won't go too much into this, but when the system grows, you know, increasing team size or the number of teams, or talking about feature teams or component teams, which is one of the things nowadays when you talk with the people, agile people, feature teams, bang on, component teams, yuck, yeah. Unfortunately, reality is always more complex than that, yeah. So when the system size grows, yeah, sometimes you have to involve more people in it, simply because of more aspects to take care of, more things. And this is an architectural concern, okay? As I mentioned at the beginning, you cannot let project managers take these decisions alone, okay? If you see them trying to take this decision, lock them in a room with no access to telephones or anything, yeah? The thing is, because we know Conway's law, I don't have the reference here, but there is a paper from the Harvard Business Review that actually tested Conway's law for real to see if it was a real thing, and they found out that, yeah, well, actually is, yeah? And so you want to, when the system, you need to do more. At that point, you may decide to take some design decisions because you probably want to organize the teams in a way that is convenient for you. So ideally, if you had all feature teams, it seems to be the ideal scenario because they take each feature end to end, yeah? And there are fewer communication channels in terms of getting stuff done, yeah? But also you have to remember that often your feature is my component, nowadays, especially on the web with several systems. So it's kind of, it's not a clear-cut thing, you know. Could be a feature for somebody, could be a component for somebody else, yeah? And also, in general, if it is one system, doesn't matter if all feature teams, because there will have to be some component that is common, because otherwise, it's not a system, it's a bunch of systems. And then you don't have the problem in the first place, yeah? So it's something I won't go on for much longer here because I actually have a talk about these things as well. But it's something that is very important. Okay, you need to take these into account. Okay. And the other one is what do you do in brownfield and legacy systems? Is actually use exactly the same techniques. But since you are starting from something existing, the thing is, how do I choose where to start? Yeah, so I've got a legacy system. We need to do stuff, and we want to fix it. Where do we start? You know, the whole thing is a pile of shit. You know, where do I start? My shovel. Now, a typical pattern that the big companies follow is rewrite from scratch, which is interesting because even a project I'm working on now, they had one system, then they rewrote from scratch a second system, and they ended up with 2. Now we are working on the 3rd one, and we've got 3 at the moment. How cool is that? You know, we don't do any more work in the old system, but actually we do because we have people using it say, we want this. Yeah? So a better approach is having an idea of where we want to go, you know, an hypothesis of what a new system could be, but then using some kind of strangler pattern or something. Basically is new stuff, start designing new bits, yeah, and start removing old bits for the old system. This is the idea. Obviously, there are some details, some implementation details left to the implementer.
This is exactly why I'm here, because I'm in the middle of this at the moment, where everybody's asking me, what's the architecture as license manager for this new, what architecture should we be doing? Because it's just sort of grown up into a mess. And I'm saying, I don't know. I mean, I can't even see what the stuff's doing at the moment, so I'm just having to go in there, clean it up, and actually I'm finding, oh, right, I know I want to do some table-driven design, I reckon that's going to work, and I can start putting stuff out.
But and why did I put this book? It's the latest book from Adam Thornhill. It's the best book I've read in recent times. I was one of the technical reviewers of these things. And when I received the first PDF draft, I was truly excited for the first time in at least 15 years reading a technical book. Nowadays it's more, okay, yeah. This one was, oh, because it gives you a way of looking at your system from the information you've got in your Git repository or somewhere else. And then you can see, basically, you see where you need to start. There are parts of the system, software systems usually obey to a power law, yeah? Bits of it get modified all the time, yeah? And probably have most of the bugs. And the rest of the system, just you don't touch it, ever. So analyzing what you've got there, some techniques explains, like you can see which modules you change more often, you see which ones have more test issues or things like this. You can actually decide where your attack points should be. Yeah, where do you start? Well, start from the places that probably you modify all the time. Probably those are important bits that you need to redesign. Yeah? Anything that is there that never gets touched and always works, well, leave it last. Maybe you can even leave it forever. Yeah? You don't want to worry about those bits. You want to worry about the bits that are creating pain now and are really important. And you can see that just analyzing what you've got, which is a pretty powerful thing to do. Yeah? So it will give you at least some starting points on deciding how to improve the current situation.
Isn't there a small hidden assumption there that the goal and functionality of the system going forward is the same as the goal and functionality of the system that's extant?
Well, it depends, of course, on the system. But often, when you have a legacy system with a new one, what I see is that often you want the new one that does whatever the old does, plus whatever you are unable to implement in the old one.
But isn't that first one the assumption that what it does now is what you need it to do?
There is an assumption there, but it's not necessarily, you see, if you work in this way, it's not necessarily the assumption, because what you are touching there is the things that you keep modifying and touching, so probably that is important. And the stuff that never changes, that is working or just never changes, you probably discover that you don't want to bother with it at all. So this is why it is also an interesting way to get some.
I'm working with a project now which involves a rewrite, and that seems to be driven entirely by changing needs for software quality attributes. Functional requirements, as far as I can tell, are almost identical.
Yeah.
It's basically because they can't hire Lisp programmers and they can hire Python programmers.
Yeah. So yeah, sometimes the quality attributes can be all.
In my situation, it's a case that I've actually got to keep the existing functionality, because that's making money at the moment. And yet there's a wish, we're discussing with more customer-facing side, that actually, yeah, we want to change how you drive the licensing. But you can't see how to get that transition until we've cleaned up the crap here. And then you start to say, okay, yeah, now we can pull it out. But you've still got to keep, you've got to keep the existing revenue stream going. So I'm in that halfway stage where I know it's not right. Yeah. I've got to keep it going. You've got to pull it into the new one. I don't know where, you sort of don't know where you're going. Well, you know where you're going.
Yeah. Okay, and then I've eaten already 17 extra minutes, so thank you very much.